So my dear students, today we are going to see this lower bound theory. What it says, lower bound theory concept is based upon the calculation of minimum time that is required to execute an algorithm, and lower bound theory is used to calculate a minimum number of comparisons required to execute an algorithm. So from here it is clearly visible that if the comparison required, if the comparison is lesser, so the time will be the lesser to execute an algorithm. So in asymptotic notations we have seen that how we are going to bound an algorithm by giving its upper bound and lower bound. So upper bound is given by big O notation and the lower bound is given by big omega notation. Okay, now according to lower bound theory, for a lower bound ln of an algorithm, it is not possible to have any algorithm whose time complexity is less than ln for a random input. What it says that suppose if we have a problem, and for that we have algorithms, and that is A1, A2 and A3. Okay, so we have three algorithms to solve a problem. So if a lower bound is decided for solving this problem, and that is for n input. Okay, so problem is for n input, and we have designed algorithm for by taking n input itself. Okay, n is what? So for any algorithm it is not possible. So we have three algorithms for solving this problem itself. So for it is not possible for any algorithm to this algorithm is having the lesser complexity than this ln, which is pre-decided. So once we have decided the lower bound to solve an problem, so whatever be the algorithm we have for n inputs is not go lower down than this ln itself. Okay. Once the lower bound is calculated, then we can compare it with actual complexity of an algorithm, and if their order are the same, then we can declare our algorithm is optimal. If this algorithm is designed to solve this problem, and if it is having the same nature of this one, then this algorithm is said to be an optimal one. Okay. So the techniques which are used by lower bound theory for obtaining lower bound are comparison tree and techniques for algebraic problems. So there we are going to use the lower bound theory itself. So comparison tree we are making while we are searching some elements and we are doing sorting kind of things. Okay, we'll see that. So the comparison based algorithm defines a decision tree. Definitely when we are doing comparison while sorting the elements, while searching the elements, we'll do the comparison. So for that we'll have to make a decision tree. So our decision tree is a full binary tree that shows the comparison between elements that are executed by an appropriate sorting algorithm operating on an input of a given size. It means while making a tree, we'll have to take decision at each point, at each level, or at each node we'll have to take decision. Then only the tree length grows or will move downwards to the tree. So we'll have to take decision at each node itself. Okay. So in a decision tree there will be an array of length L. So we are going to see an example where we are going to take n length elements. Okay. And we are going to get the total leaves node, that is n factorial. We'll see an example. We'll try to understand this one. So this is the decision tree I have made there. So It is clearly visible here. We have a decision tree for finding the minimum element from a given 3 elements. So from 3 elements we are going to get the minimum element. So whatever be the element we have, that is 3, it should be 3 in nature. Okay. So if A1 is, let's try to take any element, that is 6, 7 or 8, whatever you want. Here we took 1, 2, 3. Okay. So if A1 is less than A2, see, if A1 is less than A2, if it is true, if this part is true, sorry, if this part is true, what does it mean? See, it means A2 is greater than A1. If this is true, this condition is true, it means A2 is greater than A1. Now we are comparing this A2 with A3. Okay. So see, if A1 is lesser than A2, yes, then we are going to compare A2 with, we are going to identify the minimum element. So that's why. If it is true, so A1 will be the lesser than A2. Now we are going to compare this A2 with A3. So which will be the lesser? This part is saying yes, and this part is saying no. If this is true, we are going to get 1, 2 and 3. Because A1 is lesser, then we will checking with A2. So A2 is the greater, it means. So A2 will going to compare with A3. And if A2 is lesser, this is yes. So the second list element is 2. And the second and the last list element will, because we have 3 elements, so this is the 3. And we will have this one. So if we will take 6, 7, 8, we are going to get 6, 7, 8 here. So by having this condition, so for each node, see, if A1 is lesser than A2, condition is false, it means A1 is greater than A2. So we are going to check this A1 with what? A3. So we are going to check this A1 with A3. Again we have condition yes. Again we have condition no. Again we have condition yes. Again we have no. Yes. No. Okay. So how many leaves node we are getting here? See, 1, 2, 3, 4. This is 1, 2, 3, 4, 5, 6. And that is nothing, that is 3 factorial. Okay. So see, here we have n leaf nodes. Okay. N factorial. So we have 3 elements. We have 3 elements. And we have 3 factorial, this leaf nodes, that is 6. We know this is a binary tree, and what will be the complexity of this binary tree we know very well, that is height of the tree, and that is nothing but height of the tree is going to be the complexity of this tree. So each level will have to take the decision to move forward, and what will be the complexity of this one? That will be the height of the tree. So what will be the height? It will be going to give you the complexity of this tree itself. So we are going to lower bound is what? Height of the tree. Okay. Now see the second point, that is technique for algebraic problem. Techniques for solving this algebraic problem we have. That is a straight line program. So what it says, the type of programs built without any loops or control structure is called straight line programs. So we have here, if here we have written addition program, simple algo is there. A plus B is assigned to C, and we are going to return this C. If you want to eliminate this function here, you can eliminate and write a simple program also, int A equal to 10, int B equal to 20, int C equal to A plus B, and print that C itself. Okay, so this is a straight line program where we are not using any kind of control structure. Okay. Now, so the algebraic problem can also be solved. Algebraic problem can also be solved by using this lower bound theory. So we have this one. That is what? Ax square b square plus c is a polynomial equation. So we can use this one by using also lower bound theory. So we are going to bound the lower side. So this is a simple approach how we are going to solve this polynomial equation that I have written earlier. Right now we have this. It is a square plus bx plus what? C. We have written. So that is what? Ax v equal to, do we have what we did here? Basically we have written one line assignment, and that is going to take a constant time, constant time, constant time, constant time, and constant time. Okay, excluding this one. So it is going to give you constant time, constant time, constant time. Okay, so the complexity for solving here is 4. Complexity to solve here, it is going to take you 4, and that is what we have taken polynomial equation of 2. We are getting here time 4, and that is what? That is what? N square. N is what? Polynomial equation depends upon this one. We are going to get this one. So that is 2 cross 2, and that is going to give you this 4. So that is how we are going to take the complexity. So what is happening here? Try to understand how we are going to solve, going to get this one. So we'll write this a cross x, and now what we'll have to write? V plus b. So see, this is v, and v is what? V is what we have right now. V is there. So what we'll write here? V is right now a plus x plus b. Till here we have this one, because v is what? V is this. Okay, now say this one. So v multiplied by, again, this with this value is now our v till this point. Okay, so v is having this value. Now consider here itself, we are going to write this a cross x plus b whole multiplied by what? X. Yes or no? Very good. So it will going to give you that a square, ax square plus what? B of x. From here we are going to get, now it is what? It is what? It is v, and so in answer what we are writing? V plus c. So this is v, and now we are going to plus c here itself. So c. So this is the equation. So the polynomial equation can be solved by using this one also. It is clearly visible. So what we have right? We have used here simple approach without any control structure. See how we are going to lower bound it. So if I'm having n number of polynomial equation, we are going to get n square. Okay. Let's see. I have written an equation here. So that is by using loop itself, and we will try to lower bound. See, clearly visible, we have only one for loop is there. We have only a for loop given here. So if we'll have an equation like this one, ax cube plus bx square plus cx plus what? Plus d. If we'll have this equation, I want to solve by using this one, initially v equal to 0. Okay, it will start from 0 to n, so it means n to 0. So we are going to take n to 0. It means we have 3, so we'll start loop from where? From 2 to 0. From 2 to 0. So initially v is 0 here. A is what? Ai. So initially we are going to take the element of this one. Ai is what? Initially v is 0 plus v. Ai is what? A and what? Element x. Initially we have this one, and this is the value of v. Similarly, question we are going to get the value itself. Okay, now again we are going to calculate. This is for 2. Now what will happen for 1? Again we'll have move there. From we are going to get v equal to, again what? We have this value in v, so we have a x only there. Yes or no? We have only ax. Okay. plus a of I is what? B. Now we are talking about a of 1. We have here 1. And we are going to multiply with what? X. So we are going to get what value? Ax square plus b of x. Again we are going to take, this is 0, for this 0, again we have this v, and we are going to multiply with x plus, this is our, this is our v, plus we'll have to write c, and then we are moving inside. Okay, then we'll move inside for 0th element. X square plus bx is what? This is our v. Ai is what? This c. Okay, this c is what? We have this, and x is what? This is. So this is going to give you what? This is going to give you ax square, ax cube plus bx square plus cx, and whatever the constant is, we are returning this one by giving some constant. So that is c is given. Okay. So we are going to get this 6. So whatever is the constant, we are going to write here, that is nothing but this is what? This is p. So that is how we are going to see that we have used only a for loop to solve this problem, and the complexity is going to be n. And this is way of solving such equation is called Horner's method. Okay, and we are going to get the lower value of n. So there is no algorithm which will give you the complexity lesser than this n itself. Okay. Now, introduction to parallel algorithm. So what is this parallel algorithm is that, so if we do any work in parallel, so we know this one, that the work will be get faster, the work will be done faster. Okay, get done very faster. And if we'll do in sequential manner, as compared to sequential manner, it is doing work faster. So we'll have example here. See this example here. You can to know this, how this work we are going to get the faster work. Okay. Now see, we know this one. So if we have given a work, and if we are doing sequential manner as compared to parallel one, sequential will be get more time if the value is larger. If the value is smaller, if you have a small task, then go for sequential approach. If you have a big task, then go for that parallel approach. Okay. So what approach is there? Parallel computing is a technique in which given problem is subdivided into many subproblems so that each processor can work on a subproblem, and solution from all processors are collected together to form a final solution. And that is what parallel computing is working. You know this one. So we have sequential algorithm for this one. You know this one, and we have this parallel algorithm. So any given problem can be solved in two ways: using sequential model or using parallel model. You know this one. Okay, let's see. So in sequential model, what happened? In sequential model of computation, the entire problem is divided by a single processor. On the other hand, in parallel model of computation, the subproblems of a given problem are executed by multiple processors. Okay. The sequential model of computation is called random access machine. In random model, one task takes 1 unit of time. Okay, this is for sequential algorithm. Okay. Now, the parallel computational model can be categorized in two types of machines, and that is what? A fixed connection machine and shared memory machine. So for fixed one, we have processor that is linked, and that is what fixed. In fixed connection machine, each node represents a processor, okay, and the edge between the processors are for representing the communication link, and that is for communication link. Okay, good. In shared model, there are n processors who share a single global memory. So we have a single global memory, and that will be shared by what? It will be shared by processors. This model is also called a parallel random access machine. So PRAM, parallel random access machine. Okay. So all the n processor in this model works synchronized way, and they are working over there. Okay. So the communication between the processor is done through the global memory. So this memory is what? This is our global memory. Okay. Where all processor will do work. This is the processors P1, this is P2, and this is what? This is global memory we have. Okay. So let us suppose that we have 5 processor, and processor 2 wants to communicate processor 5. Then the first processor 2 will write some message to memory cell. Then processor 5 will read memory from cell 5. Okay. So what I'm trying to tell you here, that if we are doing the parallel, if we are using parallel algorithm, then we have a situation that we have to take care of that one. That is, the major problem in shared memory model is the occurrence of conflicts. A conflict is a situation in which two processors access the same block of memory at the same time. So this P1 will try to access this one, and P2 also try to access this one, and that will generate the conflict. So to take care of the conflicts, we have some approaches are there. Okay, so to resolve this conflict, first one is EREW. EREW. That is, it means exclusive read and exclusive write. In this model, no concurrent read or write is allowed on any cell of global memory. It means concurrent, at the same time, no two processes are allowed to access this cell. Okay, this is EREW. Second one is CREW, and that means concurrent read and exclusive write. That means two different processors may access same memory cell, but the same memory cell cannot be written by two different processors. Okay, it means, so they can read here, but they cannot write. Okay, so concurrent read, exclusive write. For writing, they will work independently, but for reading, they can use parallel. Okay. And last but not the least, that is must tell you, that is CRCW, and that is means concurrent read and concurrent write. Okay, that means both concurrent reads and concurrent writes are allowed for particular memory block. The only necessary thing in such in such parallel random access machine model is to decide the priority of the operation. That's why then we will do this concurrent read and concurrent write. Okay, so hope that concept will be clear to you. Okay, thanks.